Hello everyone and welcome back to a new episode of ILU BIM series. So in the previous video we have seen how we can use the Navigate rebar extension and Revit built-in reinforcement option to add reinforcement in your model. But in reality you will have to first design your reinforcement, how many reinforcement are needed in the foundation, columns, beams, slabs, and then you will have to provide it, or you can just directly provide it in during the design phase and then bring it back to Autodesk Revit if you are working in Autodesk robot structure analysis. So we would be following that, but before that I did some changes in the model. If you see, I have added this new level, which is level 0, 3 feet from bottom from the ground. This is because just to give a space for excavation, so a 3 feet excavation would be executed, and then these foundation would be laid out, then the columns, the beams, and then it would be covered and filled with earthwork again, and then our floor would be laid, and after that our structure is going to proceed till the last story. So one element is still missing, that is the stair. For the structure design, let's use the floor approach, because we are going to add reinforcement in the floors while we are designing it. So it would be designed as like inclined or floor with some slope. So let's go to the level 1, and I am thinking to add stairs in this portion here. So let's add our stairs here. So let's first calculate how much length is from this beam till this beam. So let's go to measure tab and let's measure this. So we have 11 feet of length. So we have 11 feet of length, and if we keep our riser width equal to riser thickness, riser one is its width, one is its width, one is its length, and one is its height. So let's keep its width as 1 feet. So we will have it is 11 feet and our height is 12 feet. So we would need at least 24 stairs. So let's keep 12 stairs first here and 12 stairs here, but you see we cannot provide 12 stairs equal to 1 feet up width, but we can take 10 inches for instance. So for 10 inches we would be needed a 60 inches. So how much is 60 inch? So let's go to the architecture tab and draw our model line from here till 60 inches. So this is 60 inches. So for till 60 inches we would have 6 stairs and another 60 inches. So it is like here. So our stairs can come till here, but we are going to provide it in 3 steps, like 1 stairs, then landing, then another set of stairs, then landing, and then another set of stairs. So let's keep our stairs width equal to 3 feet. So if we keep it as 3 feet, so we will be 3 feet distance from here, 3 feet distance from here, and the same 3 feet distance from here. Let me remove these extra lines and let's draw some reference lines for us. So these may seem like laborious, but once we start working on it, these would be really helpful. Like now I am going to start my stairs from here, and then it would come till here, then there would be a landing here, then it would come again till here, and then it would be another landing, and then it would go to the upper floor. So how are we going to do that then? So let's go to the structure tab, then go to the floor tab, floor structure, and let's make another type of floor for the stairs. So I'll click on the edit type, give it a name, and let's take it as 4-inch stair slab. Let's change its default thickness to 4 inches. And let's draw our roof or floor, stair floor till here. Let's give it a slope area, so it will have a slope, it will have a downward slope till here. Let's finish this and see how does it look. Save the project. Okay, it's fine. Okay, let's check it in the 3D and see how does it look. So you see now it is looking like this, but we need it till half the distance. So if you click on this, and now let's change some of the dimensions here. So it is going down, and you see height opposite at the tail it is 1 feet, and at the head it is 0 feet. So at the tail, let's take it as our total length is 12 feet. So let's make it as 5, 5, 10. So let's take it as 4 feet. Say apply, and you would see that our height is now increased. So this is done. We can now mirror it to the other side and then change its orientation. So let's mirror it to the other side. So now it's mirrored like this. Now I'll click on edit boundary and change its slope from here to this point. So we can change its slope direction, or we can just click on this and then we can then mirror it from its center and turn off the copy option so it doesn't copy. Slope arrow would be going down till here. It's fine. And let's make the changes. So at head now it would have it would be 8 feet, and at tail it would be 12 feet. So let's click on apply and see our model is done. Continue. What error do we have? Structure full length and direction not satisfied. Okay, so we don't have the span direction, so this is actually our span direction. Okay, so we have these two stairs floors like this, and now we have to add one floor here, one here, and another floor from here to this direction. So we can now change its height like this. So now we have to add 3 more slabs. So let's go to the floor again, the 4 stairs, then this one. Now we will have these flat, and its offset from the level would be 4 feet. So apply. Okay, now we'll add another one. It would be here, and it would be 8 feet. This is done. Now let's add another one here. So it will be from here to there. So let's add our floor here, and then select the rectangle, and from here till this direction. And now let's add the slope arrow. So slope would be from here to this point, and at the tail we would have 8 feet, and at the head we will have 4 feet. Click on apply and see how this is modeled. So it's fine. Okay, so we have made this in the level 1. Let's bring it to level 0. Okay, still not fine. Don't know what is the problem. Let's see. Okay, so now let's make it 0, and let's this make it level 1. So it's fine. So actually it was at the offset of 1 feet. So now this is fine. It's like this. I know the slope is a little bit weird, but we can then change it. But let's first take it like this. I think it's fine like this. Okay, we can now I think it is fine like this. So now if you want to add a beam here to support these spans, actually, so a beam here and a beam here, you can add that too. So for that you will have to go to the beam, and now we have our 12 cross 18 inch beam here, so we can add a smaller beam here. So let's make another beam and call it stair beam. Okay, and let's keep the breadth as 1 feet, but the thickness or the height as, let's keep that as 1 feet 1 feet 6 inches too. Let's keep the same beam here, and let's draw it, but its Z offset would be now its Z offset would be, the first one was at 4 feet, so it would be at 4 feet. Apply, and let's write like here. Okay, so we have this beam, and then another one would be at 8 feet, and it would be from here to here. And you see these are very big beams which are not that much necessary, but we need it like this. So let's keep it this way, or we can just decrease the size of these two beams. So we can just make change in one and then convert the other one to that one. So let's edit this, duplicate it, and give it a name of stair beam. Okay, and let's decrease its height to somehow 8 inches. Okay, so we have this beam like here, and let's copy it from here to this portion. Okay, where did our beam go? Let's change its type from 12 cross 18 to stair beam. So we have these beams like here now. So now our structure model is ready, and we can make an opening for stair here. So for that, let's go to the level 2, and here you can see our stair are coming from this direction. So we can click on this floor, and then from edit boundary we can remove this extra space. So for that, you can click on this, now this, like this, and now just use this split command to actually divide this line at this point, and then we can use the trim command and get rid of the extra line. So now our spacing is ready. We can also make spacing here. So let's do our spacing, let's do till here. So we can then bring these like here and get rid of this line, and then just finish our floor. So now this is good. Our floor is like this, or we can also delete the whole portion of this floor. It's on your use. If you need it, so you can take it, or you can also delete it. So let's keep it this way and see how it is affecting our structural model. So now our structural model is complete. It has the floor, it has the foundation, it has beams, it has beam for stairs, and it has also the slabs, supports and landings for stair. So let's shift this model from Autodesk Revit to Autodesk Robot. If you are interested to see how the analytical model is looking, so you can just go to the project browser and click on the analytical model in 3D views to check its analytical model. So you see these browns are the floors, these lines, the vertical lines are the columns, and the horizontal lines are the beams, and here bottom you can also see these are our supports. So once we shift it to the structural robot analysis, Autodesk Robot, you will also see its 3D view in that software. So to shift it to Autodesk Robot, you have to click on the analyze, and under analyze, once you install robot structure analysis, you will have this option, robot structure analysis. Just click on this drop down and click on robot structure analysis link. Once you click on the robot structure analysis link, now it will ask you what do you want. So we are going to send our model for structure analysis to Autodesk Robot Structure Analysis, and we want a direct integration, so we can then bring it back from robot to Revit. So just click on OK, and you can also check the other options. So the case that contains self weight, so you see at DL1 it contains the self weight of all the beams and slabs and the columns, etc. If you want to ignore the self weight, you can also click on this and it will ignore this self weight. Click on OK and then click on OK, and now it will open the Autodesk Robot Structure Analysis and load this model in Autodesk Robot Structure Analysis. So now it is exporting our model from Revit to Autodesk Structural Analysis, Robot Structure Analysis. So now it is asking us that an error has occurred and the application will be terminated. So it's some kind of error. So let's do it again. So I'll open the software again. Okay, so the model has been exported to robot structure analysis, and now this message would appear that integration is completed and the warnings are being reported. If you want to see, you should click on yes. So you click on yes, so it will tell you what are the warnings. So you see there is a warning here, and the warning is about the robot structure analysis regional settings are not set to the United States. So this is not a big warning which you should be worrying about. So you can close this and change the settings where they are needed. So just close on this and see this is the model which we have made in Autodesk Revit, and you see it is now loaded in robot structure analysis. So these boxes are fixed supports, which are actually our foundations of the columns. These vertical lines shows with the numbers, these are actually showing the columns, and these horizontal members are lines are showing actually the beams, and these are the gray ones are our floor. So if you want to see this in the 3D view, so you can click on here, section shapes, and you see it will show you this all the section shapes. So now our columns and beams shapes are being generated and shown here. So if you want to check the floors too, so you can right click anywhere in this canvas and click on the display. Once you click on the display, just go to the panels, and in the panels you see the panel thickness is unchecked. So once you check the panel thickness and click on apply, so you see your floor thicknesses would then be shown here. So this is how you export your model from Autodesk Revit to robot structure analysis. So I think this was enough for today. Most of the time we have worked in making these stairs. These were also important. So let's do further steps of assigning loads on these floors, and then the analysis and design in the future videos. Till then, take care, and I hope you have liked this video. So if you have really liked this video, give it a thumbs up, leave a comment, which would really help me in making further videos, so which would actually motivate me. So another thing, if you want to see, this is the plan view, so you can also check the plan view. Here is the plan view, and you can go to the top and bottom level from here. So you can click from here, and then from here you can select which level you want to go. For example, you want to go to level 5, so this is the level 5. To go to the base level, so this is the base level where we just have these footings. So I think this was enough for today. Let's meet tomorrow or any other day in the next video. Allah Hafiz.